My best.
All right, this is Math221b. We are group 6. This is our lesson 9 meeting. Let me share the screen. Can you see that, Spencer?
Yeah.
All right. So what I'm gonna do is we'll start with part 2, and if we need to go over anything else, let me know.
Okay.
Basically, this week was talking about something we talked about several lessons back, which is the known alternative hypothesis stuff. Let's go into more detail on that. Before we start part 2, any questions on part 1? Anything you need to go over?
No.
So part 2, I'll read the first section. The Graduate Management Admission Test, GMAT, is used as an admission criteria in many Master's of Business Administration, MBA programs. Scores on the GMAT in the past have been a mean score of 529. BA professors feel that the score has improved in the last couple of years. So the first thing they're asking us is, what is the null with alternative hypothesis? So it's a little hard to write it on the computer because it's like Greek letters. But essentially, the null that you should have gotten is 529, and that is what the mean that is the parameter. That makes sense?
Yep, it does.
All right, and then what you're testing is your alternative is that the score has improved, so it's greater than 529.
Yep.
All right. B, suppose you got evidence that the null hypothesis should be rejected. However, in reality, the mean scores of the student taking an exam is still 529. The type 1 or type 2 error committed. So be quick. Type 1 means that you try and basically you reject the null when it's true. Type 2 is you don't reject the null when the alternative is true. That makes sense?
Yeah, it does.
All right. So B is a type 1 because you reject the null when it was true. So C, its analysis was done at a 0.01 level with a probability of committing a type 1 error. Basically, this number right here is the. Go ahead.
Sorry, my kids are.
Okay, it's cool. So it's this number right here is actually the level of significance, and what that means is this is how much % chance there is of committing a type 1 error. So this number right here is it. That makes sense?
Yeah, and it isn't like between 0.1 to 1 or 1 to so 0.1 to 0.01, right?
Well, yeah, basically the what it is this level right here, which is mostly small, is the level of chance you have of committing a wrong. So if this is high, then you don't want to do the experiment because it means that there's a high chance it's going to be wrong. So this level right here means that your level of committing a type 1 error. So if we want to, but this is where we get into which type error we want to commit, because at D it talks about if you want to decrease the chance of making a type 2 error, we would need to increase the chance making a type 1 error. So basically the difference between type 1 and type 2 depends on the problem. But say for this one right here, type 1 means we reject the null when it was true, and type 2 means we accept the null when the alternative was true. And so the difference depends on the situation, which one you'd rather have more of a chance of getting right. So in the video, they use a good example, which is the justice system. That in America, we are innocent until proven guilty. So would you rather have an innocent person be proven guilty, or someone not guilty, someone who is guilty be proven not guilty? That makes sense?
That does.
So in that case, we would probably have type 2 be our solution, because we would much rather see someone who is. Now, I don't want to say I don't want to say someone. We want to see someone guilty be not guilty, but because we do believe innocent to proven guilty, we don't want an innocent man to be guilty.
Exactly.
It all depends on the situation. Which one you'd rather have the probability be of? So it's very situational in that. Then going on to 10, you want to read the section?
Got it. A study by the National Association of Realtors reported in 2004 that second home sales accounted for more than a third of residential real estate transactions. According to the report, the average age of a person buying a second home as an investment rental property was 47 years. Assuming the national standard deviation was 5, a real estate agent wants to determine if the average age of those buying investment property in his area is different than the national average. Randomly selects 15 of his clients who purchased an investment property and obtains the value. So AA designed the study. What is the population from which the realtor obtains his data? How did he sample the population? What is the research question? And second, oh, that's what.
Yeah.
Okay.
So this before you go over mine, why don't you read me what you got?
You know, to be honest, I have not gotten this far.
Okay, that's cool. Basically, you remember what population is? It's what you're looking at for. So his population is his area different than the national? So, well, that's the research question. But so the population is second home owners nationally.
Okay. Go ahead. Sorry.
All right, it's fine. So basically, what you're looking at is a random selection of his second home buyers and trying to see if his average age is different than the national. And so this was kind of complicated, but it's not a greater than or less than. It's just, is it equal to or not equal to? So you're so they don't ask for the no or alternative, but basically the no in this case would be it's equal to 47, and then alternative would be it's not equal to 47. And there is a range of the standard deviation here is 5, which means that as long as their difference is if the difference says the average age is 40, that would be an unusual number. But if his average age is 45, that's in the standard deviation, so it's not a big deal.
Hold on one second, bro. I'm gonna.
No, go ahead.
I'll be right back. Oh, I'm so sorry.
No, don't worry about it. I hope you don't take it offense. I have dogs, so I'm used to hurling people around.
Yeah, man, they're rough. All right. So sorry, now I'll be able to better focus because they were just yelling and screaming.
Yeah, no, it's cool.
Okay.
So B is collect the data. Name at least one way the realtor could have randomly selected his sample. Basically, all this is asking is for how will you get a random sample with this data, and it's not a hard question. All say is so we could have always plans down an Excel sheet, number them, and use a random generator. It's not hard to get a random sample.
Very true.
Then you want to read C?
Oh, I got it. Describe the data graph, the data on a histogram. Sketch the histogram below, or cut and paste.
That's good.
Yeah.
All right. So basically, what you use a quantitative statistics sheet. Input the data you have up here, right here, into the quantitative statistics. Give you the histogram, and then I didn't write the paragraph, but basically what you're describing here is I would call it bimodal, but you could also describe it as bell-shaped. Because it has a sort of common. There are two outliers here, and what we're partly we're looking at is that we know the mean is 47. Our mean is 46.73. The average national mean is 47. That's really what we need to know more. The histogram is that our mean is how similar is our mean.
Yeah, and so the mean here was 47, right?
So the mean on our sample was 46.73. The mean in national is 47. So there's not big enough difference to prove anything.
Okay, so
that makes sense, because basically the idea is if it's 2 standard deviations away, then it makes it. So because our standard deviation is 5, it has to be above or below 10 of 47. So if it was 37 or 57, anywhere less than 37 or above 57, it would be unusual. But as I mentioned, we're looking at anything unusual, it has to be more than 2 standard deviations away.
Gotcha, you're right.
That tricky part is recognizing what's unusual, and again, it depends on the standard deviation. The standard deviation was was 0.05, then yeah, it would be unusual.
Okay, gotcha.
All right. As long as you get that, that's kind of the key part today. All right. You're going to read. So, do you have a null or alternative hypothesis? Do you understand that?
Okay, that is one thing. I know the null, and so the null is simply
status quo. Yeah.
And then the null, the alternative would be what we're trying to prove.
Yeah. So null means this is what what we believe to be true. So in this equation, the null is 47 because that's the natural parameter. So the null is often described as a parameter. You remember the parameter statistic?
That parameter is like when they had that test yesterday.
Yeah.
There would have been the census, like the census that the national people did, like the government did.
Yeah. So it's a presumed average over a large population that may not be statistically proven, but it was believed to be okay. So null has more to do with what we believe to be true than it does with the statistic. The basic difference between a null and alternatives. The null is basically you're trying to reject or not reject the null. That means you're trying to prove whether something is status quo or it is different. And so, alternative is what you're trying to prove. So, if your null is, I believe that most families in Idaho have 12 kids, and again, that's kind of weird, but and then your alternative would be anything different than 12. That makes sense?
It does make sense. And so, for this example, since it wasn't, the answer was 46.83. The mean was 46.73.
Yeah, 46.73, which we'll get to in a sec, but basically that's not enough evidence to prove the null is rejected because you're looking for two standard deviations above or below, and the standard deviation is 5, and this is like 0.25. It's not a big enough difference.
Okay, that makes sense.
All right. Do you understand the 1 and 2 tail test thing?
All right, so I know that one side of the bell chart is one-sided, and then if it's both-sided, that means like both the sides of the applet.
Yeah. So let me pull it up real quick.
But I mean, to be honest, I don't really understand the significance of it.
Yeah, give me 1 sec. I'm gonna share a screen in my applet, and that can help you with this. It's mostly has to do with the applet. What you're looking at here is what are you testing? So right here I have what is change this to 1. All right. So if it was two-sided, we would be looking at both of these sides, and anything outside the extreme, so anything here or here would be considered extreme. So most of the time, what we're going to be looking at is two standard deviation extreme. So anything to the left of the -2 or above 2 on the z-score would be considered extreme. So there's blue areas. Now, if we're looking at one side, depending on what side, if we're looking for less than, then it would be over here. If we're looking for greater than, it would be over here. That makes sense?
That does. That makes sense.
All right. We'll move back to the questions. Basically, for that number 2, null is that it is 47. The alternative is that it's not 47. This is two-tailed because you are testing both ends of the stratus.
Mm-hmm.
The 3 is just giving you a statistic number. Remember, what they're numbering you on 3 is the level of significance. So that means that we have a 5% chance of committing a type 1 error. And so this is useful when you compute the test statistics, which are P. So basically, it's computing the z-score, same formula. So you would use
the z-score method, like the z formula, right?
Yeah. So I wasn't sure how to write down in the computer because it's a lot of weird numbers, but I have it written down on my paper. What it is you're looking at z equals your sample mean, so 46.73, minus your population mean, 47, over 5 the standard deviation divided by the test population of 15, the square root of test population.
Okay.
So you remember that formula, correct? I don't need to go over it.
Yeah, we're good.
All right. And then what I got was a z-score of negative 0.2091.
Yeah.
And then I plugged it in, and I got, so this is my z-score right here. And then for part 5, I plugged it in and got 0.8344. And then this is where we got into basically the new stuff, compare the p-value. So because my p-value is 0.83 and my statistic is 0.05, then we fail to reject. So fail to reject means your p-value is greater than your test statistic, your alpha. But if you only reject the null if your p-value is extreme. So if my p-value was 0.01, we will reject it because the test statistic is 0.05. That makes sense?
Yeah. So is that saying that we reject null hypothesis?
No. So fail to reject.
Oh, we'll reject the null hypothesis, right?
Yeah, so basically we're only talking about the null. We don't talk about the alternative, but when you talk about in English, it's fail to reject or reject.
Gotcha, yeah.
And we only reject when we have significant evidence, which is considered anything, any number below the alpha. When alpha should be low, because that's our possibility to mean type 1 error. If your alpha is high, then the science needs to be rejected anyway because you have a yeah. Then again, it depends on what you want to do, because this means because the alpha and the beta, which is type 2 error, flip-flop depending on statistics. So the only thing you remember about that is basically if you have a higher chance of committing the type 1, so you increase your type 1 chance error, you lessen your chance that you mean a type 2 error.
Okay.
And that's important depending on what your situation is. So if you're testing something where you'd rather have a type 2 error than type 1 error, then you're going to want to increase the level of significance. That makes sense. It's not covered right now, but I think it's important to know.
Yeah, it does.
All right. And then the conclusion is insignificant evidence conclude that the mean age is different. And finally, take action. You don't need to take any action because the no is true or not rejected.
That makes sense.
All right, you want to do the group quiz and we can cover stuff there?
Yeah, let's do it. How much time do you have left?
Oh, I'm good. I was confused at what time we were leaving tonight, but I'm not leaving until 7, so I'm okay.
Wait.
So we can do it. I have time.
Yeah, those videos definitely help. I really like the last one when he's up on the chalkboard.
Yeah. See, go ahead.
I didn't quite get to that one, so I'll do better next time.
Yeah. I recommend make sure you watch the ones that cover just the information, and then you will also watch the ones for the part 1 and part 2 if you feel like you still need some stuff after that.
I watched the first 2 ones where he's just simply going on his Word document the entire time.
Yeah.
But, like, I wasn't able to get to the last 2 where the guy is up on the chalkboard and he like walked you through the.
Yeah, no, it's cool. Again, I understand you're working all night, and so you come home, you have time to sleep and get work done. It's cool. You work nights, right?
I do.
That's rough.
Kicks my butt.
Yeah. All right. So, you got it up?
Yep, I'm ready.
All right, cool. Then let's do this. Question 3. What hypothesis involves equality? And that's the null hypothesis.
Okay. Because the alternative hypothesis does not involve trying to prove.
Well, basically, the null hypothesis is it's always what you are given as a parameter. So it's always null hypothesis is always going to be equal signs because you are trying to your goal is not to prove your alternative hypothesis correct, it's to disprove the null. And basically the null is always a parameter. So it's always going to be equal to, even if you're talking greater or less than, it's always going to be equal to your parameter. That makes sense?
It does, yeah. That makes sense. Yep.
You want to read this next section?
The p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Okay. So remember that the p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. When computing the p-value, which hypothesis do you assume to be true, and I would assume no.
Yeah, so the null is always true unless proven wrong.
Sweet.
Oh, it's easy. I'll read the next one. Suppose a null hypothesis H0 is mu equals 10. Which of the following is an alternative hypothesis for a two-tailed test?
C?
Yeah, it is C, because two-tailed means you're trying to disprove on both sides, so it has to be an equal sign. One-tailed would be one-tailed right or one-tailed left. It depends on what it is, but this one's easy. So we're a left-tailed test 6. You got 5, right? That was C.
Okay, yep.
All right, moving on to 6. For a left-tailed test, we are looking for the left side, which means that we want it to be less than.
So left house side. Yep, you're right. You got it.
And then right side would be the opposite greater than. So 5 is C, 6 is A, and 7 is B. That okay?
Yep, I'm good there.
All right. You want to read this next section?
Remember that we determine the outcome of a hypothesis test by comparing the p-value to the level of significance, or X.
It's alpha.
Alpha, yeah. Oh, yep, alpha. So which relationship would result in failing to reject the null hypothesis?
All right. It's A, because alpha is your level of significance. If when you're plugging it in, it's your p-value is greater than, then that means the null is true or failed to reject.
Failing to reject, yes. So
do you understand that? That it's that. Go ahead.
So I'm just trying to see why it wouldn't be B.
B.
I know C and D are definitely not true. Like, what's Z? Like, why is that in the equation? Those can't be true, but why would it not be B?
Well, because B, if it's less than alpha, that means your null is rejected. Because you're looking for your p-value is your is your probability of something happening. If it's less than your alpha, so your alpha, then that means it's an extreme number. That makes sense why it's extreme. So let me probably help you. So if our number, if we are looking for less than, and our z-score is 2, in order to be less than our z-score, you have to be over here. So our area of your alpha is going to be basically this number right here. Is going to be the alpha is going to be in this area. And so what it's going to say is that if you are say alpha is probably not 2, but basically what the alpha means is that you have to be less than the alpha to get be extreme.
And the alpha would be 0.05, right? Or
yes. So in this case, and what we did on the alpha changes every time, and part of making a good statistic project is picking an alpha that's low, because the alpha is your chance of committing a type 1 error.
Gotcha.
So basically, you want the alpha to be as low as possible because that reduces your chance of committing error, which also means that if you have a really low chance, then when you do get a number that's lower than the alpha, it's easier to prove that it is extreme.
Okay, yep, that makes sense. That makes more sense.
Because again, the p-value is your probability or area under the take. If your area is 0.01, then that's a pretty extreme value. Versus if your area is, say, if your area is like 20. So 0.2. That understand why the p-value has to be that way?
Yes, it does make more sense.
All right. So why don't you try number 9? What do you think it would be?
In rejecting the null hypothesis, well, that would be the opposite. It would be in rejecting it would be greater than.
Rejecting would be less than. I understand why.
Okay, so the one before though was sorry.
So, okay, go ahead.
Yeah, so I just got those mixed up. So the one's greater than the alpha, that would not, it would fail to reject, and the one that is less than the alpha would reject.
Yep. Okay. I just don't want you confused those because that's pretty important.
Yeah.
And it's confusing already. I know. So I'll read this section. An insurance company is reviewing its current policy rates. When originally setting the rates, they believe the average claim amount was $1,500. They are concerned the true mean is actually higher than this. So before we figure out that alternative, we need to figure out what the null is. What the null is, and null is 1500, which means that if they think that it's higher, then we're going to say C, the average claim amount is greater. That makes sense? Why?
Yep, you're right. Yeah, that makes sense.
And then 11 is what we talked about, the null. The null is equal to.
Yep.
The null is always an equal sign. Let me pull this up. The insurance company or NSC selects N equals 40 claims and calculates a sample insurance mean of X bar 1650. All right, so the insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? And
yes.
Which one do you think it is?
Sample size is large.
Yes. That's just a previous question test. And then 13.
Nah. So that would be central.
Yeah, central limits here is what's proving that if your sample size is large, it's norm distribution.
Okay.
Just checking. The following is the test statistic as defined in this lesson, and test statistic is Z.
Oh, really? Okay.
Let me double check, but I have it up here. Where did it go?
We're seeing that somewhere in the reading.
So the test statistic is your Z-score.
Oh.
That's what it is. Okay, yeah, that's why I was getting confused. Yeah, so the test statistic is your Z-score.
Okay.
Historical means of sale receipts at a grocery store is 150 with a standard deviation of 40. The store manager suspects the average has decreased. He sets up a hypothesis. If the hypothesis, no hypothesis is mu equals 150, and alternative hypothesis mu is less than 150. You'll use significant levels of alpha equals 0.05. You then take the simple random sample of 36 sales receipts from a store and compute X bar of 144.
Okay.
So what we're going to do for 15 is compute the Z-score. So let's do it on our own, and then we'll talk about it.
So my only question to you is...
Shoot.
Okay, never mind. I got it. I'm okay.
All right, cool. So let's each take a sec to compute it, and we'll talk about it.
And I'm sorry, I'm really slow at calculating this stuff, so...
No, it's cool. I'm using a calculator. Let me know if you have any problems getting the equation.
I'll let you know once I got it.
Yeah, it's cool.
So for the Z-score, I got, let's see. Wow, I got negative 0.900.
That is what I got too, so I'm going to go with that. So negative 0.9. I wanted to see your answer because it says trying to two decimal places. It's kind of like a trick thing. So go ahead and put negative 0.900, and if we get it wrong, we'll work on it again.
That's good. I'm just saying, like in nursing school, they say to never use a zero after it trials a whole number in different form. So it's different though, because this class that doesn't apply. So
yeah, no, that's fine. I did not know that, so that's cool. But yeah, since they asked for 3 digits. Okay, -0.9. And we are testing. Okay.
So you're on 16 now, or?
Yeah. So when you put this -0.9 into your applet, what you want to do is the area that is to the left, because what we are trying to prove is this less than the mean.
Right.
That makes sense?
Yes.
So I got a probability of 0.1841. This is my p-value. You get the same?
So let me, I got, hold on. I think I did my wrong. Hold on. Sorry.
Yeah, go ahead.
Okay, yeah, I got the same thing you did.
All right, cool. So 17, what inference you make about the null hypothesis for this? It's fail to reject. Do you understand why?
Let me hold on. Let me see if I get this.
Okay.
Why is because it was greater.
Yeah. So if you just go back up to question, which was it? 8. So when 8 and 9 are talking about this. So the p-value in 8 says what relation will result in failing to reject a null hypothesis? P-value is greater than A or alpha. And 9. So that makes sense.
Yes, it does.
All right. I'm just checking. I hope I'm not bugging you.
Oh, I'm glad you are bugging me because I need to better understand this stuff.
Yeah. See, I'm good at statistics, but I'm terrible at algebra, so I'm more concerned about whether my math is correct than it is understanding the logic.
Okay. So 17 is it's failed to reject, right?
Yeah. So 17 is failed to reject, and 18 conclusion is it is. And so 18 truly answers the trick. The A and B are talking about the true population mean. That's not what we're testing. We're testing alternatives. So A and B are wrong because it says that we are not testing the null. We are talking about what are alternative. That makes sense why?
Yeah.
So it is 18 is going to be C. We have insufficient evidence that the true population mean is less than.
Yeah, got it.
19, there are 2 types of errors that can maybe perform a hypothesis test. Which of the 2, which one involves rejecting the null hypothesis when the hypothesis is true? You remember we talked about this. So
it says involves rejecting the null hypothesis when the null hypothesis is true. That would be type 1, correct?
Yes, good. 20, a researcher decided that using a level significance of alpha equals 0.05, he will use an alpha of 0.01, which of the following is true. Basically, when you decrease the type 1, the type 2 error will increase. So it's B.
Okay.
That makes sense?
Yeah, it will eventually.
Yeah. So just remember, we're talking about your level significance. You want it to be as low as possible to prevent type 1 errors, but if it's too low, your type 2 errors will increase.
Not gonna lie. That's going over my head, but it's okay.
Watch the videos. It's not doing much about right now, but we will get further into it about the difference between those 2 and why they're important. Mm-hmm. So if alpha equals 0.05, compute the probability committing a type 1 error. And this one is kind of funny because it is 0.05. So alpha is your level significance alpha is your probability committing a type 1 error.
True.
I'm going to check it. Go ahead and wait a sec so I can let you know if they're right or not. And it will go over if anything is wrong.
Okay.
All right, I got 100. Let me just double check to make sure your answers are the same as mine, and you're good to go.
Sweet. So I have. Okay. So, okay. I'm so sorry. You probably are super busy, but
Go ahead.
For some reason, I'm still not getting this whole, like, but let me get these marks first. Because for some reason, I just like to write them on paper and then go back through them.
Okay.
Sorry.
No, don't you don't have to apologize. I understand. I have trouble with algebra, but I get statistics. I know people who are great at algebra don't get statistics. It's cool.
Yeah, this.
But I want you to understand it because I know that you're going to need this stuff in your future job.
No. Mm-hmm.
So while you're writing down anything you need to go over again.
Yeah, I guess I'll finish later. So the one that I was still kind of confused on, it was 20. When you were saying the researcher decided that instead of using a level of significance, he uses 0.1, which of the following will be true, and the probability of a type 2 error will increase. Now, I'm a pretty simple person, so speaking these whole like mathematical terms just kind of.
Yeah, no, it's fine. Basically, your alpha is your level of percentage that a type 1 will commit. So he lowered the level of type 1 will commit. But we know that that there is an inverse relationship between type 1 and type 2, which means that if this had gone up, then, so say he went from 0.05 to 0.06, then he would have decreased the probability of type 2. He went down, which means he increased the probability of type 2. There's a good video in in the reading. I think it's part I believe it's part 1, maybe part 2. Just check with it. They do talk about this. And so if you're having trouble, go back to that video. Also, if we meet you, feel free to email the teacher. He's willing to talk to us about this stuff.
So, okay. I think I'm good with it for now. But for sure, when I get my page of notes for the test, I'm definitely like writing this word for word.
Yeah, no, just remember, alpha is your level of significance. It determines your probability to commit a type 1 error. Beta is your level of significance that can be a type 2 error, and their inverse relation, which means if alpha goes up, beta goes down. If alpha goes down, beta goes up. That's really all you need to remember. And we're going to use alpha more than we use beta, but it depends on the problem. If you have a problem where you want a greater chance of committing a type 2 over type 1 because the type 2 is that said wrong. Basically, when you're talking about alpha and beta, you want to figure out which, in your coordinate situation, which is least bad to commit. So if you commit a type beta alpha, which is a type 2 error, is that going to be more significant or more problematic than we committing type 1? That makes sense?
Yeah, but I guess it just depends on the situation, right?
Yeah, no, it's all situational. So like you look back through the reading, they talk about, they give different examples. So I would suggest go back and do the reading a little bit more. It's how that you're rushed for time, and I understand that. So just go back and read some more. You should get it. Let me know if you have problems. I can help.
No problems. Yeah, I'm good, man.
All right. I'm going to close this up and get ready for this evening.
All right. Well, you enjoy yourself.
All right. You too. Have a good day, and see you Monday.
Take care.